Oscar. Number 1.
I don't know.
Raise your hand true. Raise your hand false. The answer is true. Class, how do you go from this -4? You set it equal to 0. 0 product rule. X plus 4 equals 0. Subtract 4. X equals -4. That's how they got that -4 there. How do you get to 6? Oh, actually, you know what? I guess it'd only be true if that was a what? -6. Book typo. If that was a -6. The remainder theorem states the remainder using function notation. So the question is, what is function notation? That's p of -4. If I take the x value and place every x value with -4, -4 cubed plus 6 times -4 squared plus 11 times -4 plus 6. If I evaluate all of that, I should get -6. Let's double check that. Class, what's -4 cubed? -4 squared. 16 times 6 is positive 96. -4 times 11. -44 plus 6. And if you add all those up together, what do you get? -6. Okay, so that should have read -6. Okay. Number 2. Brianna. True or false? Class, raise your hand true. Raise your hand false. Okay. If I take this polynomial and if I divide it by x plus 4, I get this as the quotient, and this is the what, class? The remainder. Okay, now, some of you might be asking, Mr. Ring, we did it differently in class. We did as the product x plus 4 times x squared plus 2x plus 3 minus 6 over x plus 4. Would you guys agree? So the question is, are these two the same thing? The answer is yes. If I distribute this to every term, and when I multiply it, don't do that. If you multiply it in a box, x plus 4 times this, what will happen is you'll eventually just get a -6 here, because this is 1 in the numerator and 1 in the denominator. Those will cancel. So these are the same things. What does that mean? P of x, dividend, divisor, quotient, what is it? It's our dividend. Equal to, what's this? Divisor times plus the remainder. So the answer for this one is true, because the product works. So we haven't really practiced this one as much, but I want you to recognize this is what we've done in class, and you can easily go from here to here. So we got 2 truths so far. Number 3. Ashley, what did you and people around you say? Raise your hand. True? False? The answer is true. Let me do a quick concept review. It says P of x is not, negative 4 is not a 0 of P of x. So let's just say I make up a number. So this is not related to this problem, but I wanted the idea. P of x equals a 0. We're trying to figure out if it is a 0 or is not a 0. Let's just say I make up a number. P of 2 equals 0. Class, what's the order pair? Tell your partner A, tell partner B. What's the order pair if I give you this? Class, what's the order pair? 2, 0. This is an x, this is a y. This gives you 2, 0. Class, if you graph this, where would it be? From the origin to the right 2. Does that make sense? Why am I pointing this out to you? That's the reason why they call it a 0. Because it's touching a what? It's touching the x-axis. That's why they call it a 0. So let's look at this problem over here. Everyone say function notation. This function notation is just a fancy way of saying order pairs, right? We've been working on that. So in this problem, it's saying P of negative 4 is equal to negative 6. Class, what's the order pair? If you graph that, does it touch the x-axis? No, it doesn't, right? That's why the answer is negative 4 is not a 0, so that is true. And the last one. Kevin? True. Raise your hand. True? False? The answer is true. If we did the same thing over here, P of x equals a 0, and it's telling you negative 2. Well, let's just substitute it in. Every x value from the original function P of x, we're putting in a negative 2. Negative 2 cubed. 6 times negative 2 squared, plus 11 times negative 2 plus 6. Let's simplify now. I evaluated, now simplifying. Kevin, negative 2 cubed.
That's negative 8.
Gabby, negative 2 squared. And 4 times 6. Brianna, 11 times negative 2. Oscar, negative 8 plus 24. And manual negative 22 plus 6.
Negative 16.
Eileen, 16 minus 16. Class, is that going to cross the x-axis? Yes, it is a 0. That's why it's true. So in this problem, you kind of need to know all of your concepts about using function notation, if it's a factor, using, notice how we're not actually using long division, but you could use it to simplify. And most importantly, we're using the remainder theorem. If I tell you that there is no remainder, and I prove that, that means it's a factor.